Hi, welcome to the part 2 of my function videos. In this video, we're going to look at the anonymous function, basically called the Lambda function, and as well, we're going to look at the high order functions. I'm going to take this down. Okay, so what's anonymous functions? Basically, anonymous functions are just little functions that are written without a function name, though we assign lambda functions to a variable name. Actually, the variable name now stands in place of the function name, and it's expressed in this context. Lambda, we call the arguments, and then we have the expressions. Okay, this is the syntax for you to create a lambda function, which is actually the anonymous functions. And I'll really call this shortcut. Yeah, it's a shortcut to a function, a little function definition, something that you can just throw away after using it. Now, it is applicable or same thing to if statement that is using ternary operator or a list comprehension. Just for instance, we have something like a equals to 5, and then we want to check if a actually is 5. Of course, we can do if a equals to 5. Then you can print, let me use print true. But otherwise, if let's say else is not equals to 5, you can print false. Now this is correct, and we can still do the same thing using the ternary operator. So what I can do is, let's say x, and this x is going to print the value of true if actually a is equals to 5. Otherwise, print false. Now this and the first one is still the same thing. So if I run this code right now, I'm going to have true and true. The true first comes from here, and the second true comes from here. So if I take this out now, I'm still going to have my true printed on the screen. So we have true right here. Now this is a ternary operator, a shortcut for you to do the same thing we did for about 4 lines of code. Now the same thing is applicable to list comprehension, and today we're going to talk about anonymous functions called Lambda. Now let's start with the normal div, the normal function we know. So if I want to write a function that, let's say, that greets hello world, normally we have div, and I'm going to call the name greet, and then I'm going to write my expression to be print hello world. So if I call this function greet and then run this, I'm going to have hello world printed right here. So you can do the same thing using the anonymous function, which is a lambda. So I can do that. It's simple. I'm going to call x as a variable that will hold the lambda call, and then right here, since we don't have any argument, I'm just going to leave that place blank, but I'm going to use a colon to separate the argument and the expression. Okay, now we don't have any argument, just like this one, we don't have arguments here. So the only thing we have is a print statement, and then we have hello world in this. Now at the end of the day, I'm going to call this function. So I'm going to call x because I'm calling x because we have a print statement right here, so I don't want to print this again. So if I run this code, I'm going to have the same hello world being printed on the screen. Now let me try to analyze that. It is similar to this def function. The def function is a keyword that is used to define a function, and the lambda is actually a keyword that is used to define a function as well in the anonymous aspect. Then the greet is actually the function name right here, but in terms of a lambda, we don't have a function name. What we have is a variable name that stores the result of the lambda function. So the lambda now will store the result in this x, which now be executed. So just take it as if the x right here is the function name. So it has the equivalent def to lambda. The greet actually goes to the variable name, and then the expression, whatever I want to write right here, goes to the right hand side. So let's take it up a little bit further. I want to define a function to add two numbers. I think we've done that before in the previous video. So we have def. I'm going to have add. I'm going to pass num1 and then num2 right here. That's supposed to be 2, sorry, I just used 3. Okay, so I'm going to say, let's call this addition will be equals to num1 and then plus num2. Then I want to return addition. So I can call this function by simply saying add, and I'm going to call 3 and 5. Now we need to print this, so I'm going to save this result into a variable called result equals to add that. Now at the end, I'm going to print result. So if I run that, I have 8 on the screen because 5 plus 3 is 8. So let's use the same approach to define our anonymous function. So I'm going to take this off right here, and I'm going to call the anonymous function. I'm going to call this result. That's the variable name it will be saved into. So the result is going to be lambda. Then I have 2 parameters here in this function. So the same thing is going to happen here. I'm going to define 2 arguments for the lambda function. So I'm going to call this x and y. Then what is x and y going to return is going to return the addition of x and then plus y. Now you can see that the whole of these 3 lines, although we save this to a variable name and then return it, is being done the same way in just one line. All right. So here I can now call the function result. So let me print alongside. I'm going to say print, and then I'm going to call result. From the result, I'm going to pass 4 and I'm going to pass 4. That's supposed to give me 8. Or let me change this to 5. So it gives me 9. Now if I run these, you can see I have 9 right here printed. It's actually the same thing, just very close rate to that. So let's do one more thing before we proceed to the next level. Okay, now we had something like $1. We tried to create a problem the other time that we're trying to do a conversion of $1 to Naira. Let's bring that same approach again. So I had something like Dave and I have Naira to dollar. In here I had Naira to be a requirement, and then I had dollar to be equals to 1,350. Okay, then I now said that exchange will be equals to Naira divided by the value of dollars. That's if you don't have something passed right here. Then you can now return exchange. Okay, so now we can call Naira to dollar, and then we can pass something like 400 Naira and then run that. So that's going to give us, sorry about that, I need to print this. Let's take this down for now and then print this. Let's run that again. So we have 0.296 the rest dollars. Now let's do the same thing using Lambda. So what we're going to do, I'm going to comment this line out so it will not juxtapose our work. So in here I'll have my exchange will be equal to Lambda. Now how many arguments do you really want? I need 2 arguments, as a Naira and a dollar. So I'm going to call Naira for the first argument. The second argument is dollar, and the dollar is equals to 1,350. So if a user passes Naira alone, is going to use this value to calculate. Otherwise, it's going to use both values if you're passing both values, just exactly the way the other one works. So I'm going to have my results to be Naira divided by the dollar. I think I've made a mistake right here. This the 8 is supposed to be here. Okay. Okay, so let's do the same thing by printing the exchange. We're going to call the same value. So let's call exchange of 400. And let's run that. So you can see we have the same result. Now let me use something like 1,350. You're expecting to have 1. So if I run that, I got 1.0. So let's now give $1 to it. I'm going to call my dollar to be 350. It has been reduced. Naira has actually appreciated. So that should give me about 3 point something dollars up. So I run that, I have 3.85 something dollars. So that's how you can use Lambda function.
Now let's do one more thing before we apply the higher functions into our code. Now I'm going to bring back the same code we wrote in the previous video about fetching out vowels in a sentence. So I'm going to take this now for now, and I'm going to define a variable called sentences, and that will hold some sentence. Let's say this is a test case to ensure that our lambda function is able to get all vowels from this sentence. Okay, I'm not going to write the def function. It's actually in the previous video, so I'm going to start directly with the lambda function right here. Now what I want here is I want to get all the list or all the vowels that are present in this sentence. So first I want to declare the list that carries all the vowels. Then from here, I'm going to define a function. So I'm going to say all vowels equals to lambda, and I will need one argument, which is actually the sentence. So let's call this x, and then what the x will do is to get all the lists, all the vowels that are present in this sentence, and then save them into a list. So I'm going to use list comprehension to do that. What I will do is I'll open a square bracket for list, and then I will say maybe I for I in x, implying that for every value or every single character that is present in x, which is actually the sentences, if the value of I is found in vowel list. Now remember that it is possible that you're passing a capital letter here, so we need to track that down the same way we did in the previous code. So that's going to be if I dot lower. So anything you pass, be it capital or lower, just convert it to lower to ensure that it rhymes with what you have in the vowel list. So if it's the same thing, then store them back to the vowel list. Now this is going to return a list of all the vowels present in this sentence. Let's try that first. So let's print all vowels and then pass the sentences into it. Then run the code. So you can see we have a list that contains all the vowels in these sentences. Now this is not actually what you want to do. You want to print all the vowels in a text-like form, not the list form. So what I can do here is to call the join function that will unpack the list and then bring all the characters together. So in here, I'm going to call print. You're going to print in a text-like character, and then you're going to join all the values found in the list. So now if you run this, you have all the characters, all the vowels, characters found in sentences right here. This is one way you can use the lambda function. Okay, there are other things you can just try to do with it to see how it works, but for you to be able to flow well in lambda function, you need to understand how to use the ternary operator, you need to understand how to use the list comprehension, and you need to understand how to use dictionary comprehension when you get to that level. But for now, this is the basic thing that you could learn. Learn how to use list comprehension very well, learn how to use ternary operator for if statement, and then just be trying some things about lambda, and that will be very fine with you. Now, the next thing we want to do is to bring in the high order functions. High order function is simply calling a function inside a function. So let me start with the normal def that we know and see how that works before we now move into lambda. So I will just comment this out. Now what you want to do here is to define just a basic function that greets someone. So I'm going to say def greets, and that's what the function is going to do. Is simply going to return good morning. All right. Now when you're dealing with high order functions, it's simply calling a function inside a function. So I'm going to define another function name that will call the greet function and also call the name of the person you want to greet, and then to return good morning the person you're greeting. So this is how you can do that. You have define, and what I'm looking for here is, let's say, greet name. So the first thing I'm going to pass here is the function, but I'm going to define that like a variable name. So I'm going to call this greet function, and then we need the name of the person that we want to greet. So in here, since I know that the user is supposed to be passing a function here for this very parameter, so I'm going to return greet function that will be executed, because I'm expecting this to be a function, hence this bracket. Then I'm going to add that to the name of the person you want to greet, and that's fine. Now, when you're calling this greet function, let's use print greet name. The first thing you're passing there is going to be a function, so I'm going to call this function that is right here. I'm going to call greet function. Then I'm going to call the name of the person I want to greet. Let me call it gentle. Then let's run the program. All right, I think we have an error right here. What's the error? Okay, we don't need to execute this because it's executed right inside of this return statement. So let's run that again. Now you can see we have good morning gentle. Of course, we need to put a space here to create a space between the good morning and gentle. So let's run that again. Now you can see we have good morning gentle. So in this case, this function right here is called the high order function. It is quite very basic when you're using the Lambda function to do this with the map and filter functions. Let's see how to do that. Now, I'm going to use this particular previous code we just wrote to write the same thing again, but using the high order function to do the same approach. Now, that's going to simplify our work. We're not going to need this list comprehension in there. All we need is to use the high order function called filter to take all the vowels out of the sentence. So in that case, what I will get to do right here is I'm going to take this down. All right. And the only thing you need to do is to understand how to use the map and the filter. Okay, I'm going to use the filter to showcase how this works, and after that I'm going to take time to explain the context of using the filter, the map, and the reuse high order functions. Now what I'm going to do here, I'm still going to write the results equals to, then call the lambda. But before I call the lambda, lambda is a function, right? But I'm going to write this function inside another function called filter. Filter is a function that will take the lambda function, and what the lambda function is going to do is just to specify exactly what I want to do. So I want to get x, which is present in vowel list. Actually, I need to uncomment these lines. So what this means is track for every content of the sentence that has any of this vowel list in it. And then the filter function takes two arguments. The first thing it takes is the function itself, and the second thing it takes is the iterable that the function will be performed on. So hence I'm going to call, sorry about that, I'm going to call sentence right here. Now what this simply means is track to filter every character that is found in the vowel list from this sentence. Now if I print result, basically if you are printing result of a filter or map or reuse functions, it is going to return the memory locations of that function. If I run this code, you see I'm having a memory location of this filter. So for you to have the exact content of that memory location, you need to use or cast that result into an iterable data type, which could be a list, a tuple, or anything that is iterable. So in this case, I'm gonna call lists. So when you get the result, populate it using list iterable. So if I run this code now, you can see I have those vowels present in the sentences. Now the same thing that we did over there, you can use the join method to unpack them, or you can simply put an asterisk here to unpack the content of that list. So you can see how simple it is to use the filter instead of using this list comprehension. Now the second thing I want to say is that if you're using the filter or the map method, it is quite best that you write your functions outside, save it in a variable name, then you can call it into the filter. What I'm trying to say is, instead of writing it like this way, let me comment this out. I'm going to first define my filter function to be equals to lambda x in vowel list. Then I'm going to call the result again equals to filter. At this point, instead of writing the function inside the filter, I can simply call the filter function that I defined above, then call the sentences right here. Now if I print this, I'm still going to have the same thing. So let's just copy this line and paste it here, then run the code. So you see we still have the same thing. Now this is the best approach to this. So what's the real function of filter and map in reuse? Let's take them one after the other. So let me start with the filter. I'm going to take all this down. Let's assume we have a list. Let me call that my list equals to a list of values. Let me call this 2, 5, 1, 7, 4, and 8. I have those numbers. Then I want to add 10 to each of those numbers that are there. 2 is going to be 12, 5 is going to be 15, 1 is going to be 11, 7 is going to be 17, like that to the end. Now, if you are performing an operation on an iterable that cuts across every element that is found in that iterable, you use the map function. For instance, what I'm saying here is, if I want to add 2 or add 10, like I said, to each of the content that is present here, I'm going to use map. Map means perform an operation on each items found on an iterable. So I can simply say my function is equals to lambda, and what the lambda will do is going to take one value at a time, and when you take one value, simply add 10 to that value. That's what it will do. Then now my new list could be equals to map, since I want to perform an action on each of the elements of my list. Map this function into my list. So now if I print lists, new list, I'm going to have 12, 15, 17, 14, and 18. It's mapping the function to each of the iterables. Map actually returns a true or false value when the content of your function is Boolean expression. Example, I'm saying function lambda x is actually x equals to, or let me say less than 10. What I'm saying here is, if you find any value that is less than 10 on my list, simply return true. So if I run this code, I'm going to say true, 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 all true. That's what map does. While if I'm using filter, filter does not act on all the iterables, but what filter does is look for the value that is less than 10 on my list and print it for me, or do something with it. So if I change this map to filter, it's going to return the exact values because all of them are less than 10. So let's do that. You can see we have the values right there. So if I say less than, let's assume I'm saying less than 6, that means it's going to print 2, 5, 1, and 4. Let's run that to have 2, 5, 1, and 4. That is the difference between map and filter. Now, you can also use both of them at the same time to do similar thing or something. Let's assume that I want to add 10 like I did before to each of these iterables right here. Then at the same time, after adding those 10, I want to print out the value that is less than, let's say 12 or thereabout. Now let's have a result. Let's say you have my result. Let me do a little thing that looks like real life. We have student result is actually giving us the first person scored maybe 12, second person scored 32, third person scored 59, fourth person 12 again, third person 11. Let's just give a random values like this. Okay, so now the school management said you should add 10 marks across to all the students that have written exams. So adding 10 marks means I'm going to map 10 to each of the results right there. Then after that, I want to find out the number of students that actually passed the exams, which is above 40. So what I will do now is first, let me define a function to call it add 10. And what this function will do is lambda for every x in my student list, x will be added the value of 10. That is for the map function. And then for the filter function, I'm going to print value that is greater or equals to 10. So I'm going to say get pass marks. This will be equals to lambda again. Lambda, let me call this y for now. Now what this y is going to do is get all values, that is the y, that is greater than or equals to 40. This first function goes to the map, is mapping everything, while the second one goes to the filter. Now, for you to use the two things at the same time, you have to think a little bit. Which function is more prioritized? Take for instance, we have something like this in mathematics. Let me just comment this line. I have bracket 2 plus, maybe into bracket 4 plus 6. Now, what this means is it's going to first add 4 plus 6. After adding 4 plus 6, the result will now be added to 2, which is 10 plus 2. It gives you 12. Now the question is, amongst the map function and the filter, which one is to be performed first? That is the map, because you have to map everything before you find out the number that is greater than 40. Then after that, you now perform the filter. So the list, the thing that you will do finally will actually come as an outer part, while the one that will start first come inner. Just like this bracket right here. What you do first is the inner, and what you do last is outer bracket. So what am I going to do last is the filter method or function rather. So I'm going to say result will be equals to filter, because that's what I'm expecting to be the end. What are you going to filter? You're going to filter the function get pass mark, comma. Now, for the iterable, I'm not going to use iterable here because I'm going to perform another function which will give me a result that I will now use to filter. So here I'm going to use map, and what the map will do is to add plus 10, which is the function I've defined above, to every element here, and it's going to add that into my student result. Okay, so now if I print result, remember you need to call the lists result, then let's run that. Now you can see we have 42, 69, 42, 60, 70, which is actually above 40. Now 12 is excluded because 12 plus 10 is 22, and that is not up to 40. 12 here, 11 here is also excluded. Now this is how we can use filter and map. Now let's talk on reuse. How can we use reduce? Sorry, not reuse. How can we use reduce function as well? So for the reduce function, what it actually does is to reduce the content of an iterable to a single value, just like the way the sum function works. Okay, let's take for instance, let's code that. I'm going to take this down. So I have something like list values. equals to, let's have some random numbers, 3, 5, things like that. Okay, now we can use the sum function to do the same thing that reduce does, but the difference is that sum functions only is applied to numeric characters, maybe integers or floats, but you can use reduce to strings, dictionaries, or any kind of data type as long as it's iterable. Now, what I can do here is, if I say print sum of list values and run that, I'm going to have 33. So I'm going to use the same method, but I'm going to use the reduce function to do the same thing that the sum function does. So first of all, you got to import reduce from func tools. From func tools, import reduce. Then after that, I'm going to write a function that reduce will work on. So let's call this function sum all equals to lambda, and I'm going to call x comma y. This will be adding x to y. Now what this means is that reduce performs its operation on the value from the left to the right. So for the first time, your x is 3 and your y is 5. Now 3 plus 5 becomes 8, and then your x becomes 8 while your y becomes 6. So 6 plus 8 becomes 13. Am I correct? That becomes 14 rather. So your x now becomes 14 and your y becomes 7. It keeps adding like that till it gets to the end of the value, then it returns you the total summation of whatever was in the list. Okay, so let's proceed. Let's have our result to be equals to reduce. Reduce takes basically 3 parameters or 3 arguments, minimum of 2, maximum of 3. The first argument is the function itself, which we will simply call the sum all here. And then the second argument is a list of iterable, which we have between these values. Then the third one is initial, which is optional. Well, let's start with this first two. So I'm going to print result right here. If I print result, I'm having 33. Okay. Now, if I want to I don't want to start from 0. I want to start from, let's say, 10. I have some values in my container. I just want to add more to it. So that's the initials. So initials can simply be, let's use 10 here. So I run this, I'm expected to have 43. That's what the initial does. Okay, so you can actually use reduce as well on a string, just like the way the unpacking works or the join function works. Now let's take, for instance, we have something like this, strings. Let's have this to be equal to a list of strings. I have hello. Okay, so I can do this print unpack strings. So on running this, I can have hello, I am gentle. Now this same way, this same method, or this same result can be done using the reduce function. So how I can do that is I'm going to call the same variable result equals to, first of all, let me write the function the way we normally write it before calling the result. So I'm going to call this as strings function. This will be equals to lambda, the same thing, x comma y, and this will take x, we'll add x to an empty space, then after that add the y. That's concatenations, right? So I'm going to call the lambda the reduce function now into the result variable. So you're going to have reduce. The reduce will call the string function, call the iterable, which is a strings, and then you print result. So let's run that. Now you can see hello, I am gentle is still there. Now you can as well add anything here or any way you want to manipulate your concatenations, anything you want it to do. But what it does is that it takes the first value, add whatever you want to concatenate with,
pick the second value, repeat the same thing progressively. So let's say I want to be adding a colon to every of those values. Then if I run this, the colon will be applied to each of those values. Now this is how you can use reduce function in the high order functions. So we actually talked about reduce, we talked about map, we talked about filter. This is where we're going to end this video for now. In my next video, we're going to talk about recursive functions, generators, and asynchronous function as well. I'm going to leave a little thing to work around with, something to try. And then if you have it right, just try anything and leave it at the comment sections so we can actually work on it together if there's a problem in my next video, subsequent videos. I will say bye for now. Please ensure to share my videos and don't forget to subscribe. Thank you very much. Bye-bye. Love you all.